Hello everyone, welcome to IIT-JAM Chemistry tutorial number 54, and this is lecture number 9 of the physical chemistry chapter solid state. The subtopic of this lecture number 9 is close packing in metals and metal compounds, where in the fifth part of this ninth lecture, the crystal structures of rutile and trirutile are going to be discussed. Let's start with rutile. The primary ore of titanium is rutile, from which this name is attributed. The chemical formula of rutile is TiO2 and chemically it is known as titania. Let's have a look on its crystal structure. This is the crystal structure of rutile. This one belongs to tetragonal crystal system. Tetragonal means its cell parameters are A equals to B, which is not equal to C, while all the angles are equal and 90 degree. And here this rubber lattice is formed all by the titanium cations. Titanium cation means Ti4 plus ions. Now in between there are six more oxygen oxide ions, O2 minus ions, which are actually octahedrally surrounding the uh, body centered titanium cation. On the other hand, each oxygen is surrounded by three titanium 4 plus ions in trigonal planar manner. So here, each cation, that is titanium 4 plus ion, is octahedrally bonded to 6 anions. So octahedrally, since it is octahedral structure, including the oxide ions and the titanium, then the radius ratio of cation by anion must belong uh, from 0.435 to 0.7. So since it is 0.435, it supports its octahedral structure. And on the other hand, each anion, that means oxygen 2 minus ion, it is bonded to 3 cations. So the coordination number ratio of the anion is to cation is 3 is to 6. Since the cations are forming the body-centered tetragonal lattice, therefore the number of ions within the unit cell is 2. How it is 2? Look, here all the vertices are occupied by the cation. So since 1/8 of this lattice point is inside the cube, not cube, inside the unit cell, which is tetragonal in nature, and 7 by 8 part is outside, then this type of arrangement has 8 number of ions. So 8 into 1 by 8 equals to 1. And this one within the body center. So contribution from this one is completely 1. So 1 plus 1 equals to 2. So 2 titanium are inside. Now, out of these six visible oxide ions, how many are inside? Actually, four are inside. How four are inside? This one is completely within the unit cell. This one is also completely within the unit cell. But this one and this one are on the face, on the front face of this unit cell. And this one are on the back face of the unit cell. So if they belong to the face, then half of its part is inside the unit cell and half is outside the unit cell. So half into how many oxide ions in the equatorial position? 4. If these two are axial position, then these 4 are equatorial positions. In the axial position, the oxide ions are completely inside the unit cell, while the oxide ions on the equatorial position are belonging to the face of the unit cell. That means half are inside, half are outside. So half into 4 equals to 2. So 2 plus 2 equals to 4. So 4 are inside. So the uh, ratio or the stoichiometry is TiO2O4 that supports the Ma2 type of stoichiometry. And from this also we can conclude that there are two formula units within the unit cell. So therefore, by validating the Ma2 type of stoichiometry of titania, there are two formula units within the one unit cell. So this is that's all about the structure of rutile, and this type of structure is adopted by so many other compounds, metal compounds such as stannic oxide, niobium oxide, ruthenium oxide, germanium oxide, vanadium oxide, iridium oxide, etc. Now, apart from this, there is yet another structure which is trirutile. What about this trirutile? The trirutile structure is an ordered superlattice of the rutile, that is TiO2 structure, where cation ordering occurs along the C-axis by tripling its C dimension. How? Let us have a look. This is the rutile structure, where these black spots are the cations and these large ash colored spots are oxides. Now, this is the A axis, this is the B axis, and this is the C axis. Now, if you stack two more unit cell on along the C axis, then its length along the C axis becomes twice. But before that, let me elaborate one more thing, that the number of cations are according to the stoichiometry, there are one cation and two anions. If you multiply this stoichiometry by 3, then it becomes 3 cations and 6 anions. Here you can see 6 oxide ions. These 6 are anions. But out of 3 cations, one is contributed by A, that means one particular metal cation, and another one is contributed by yet another metal cation, which is B. So the exact stoichiometry of this trirutile structure must be AB2O6. Now let me stack this AB2O6 one upon another. This is the trirutile structure where along the C-axis, 3 unit cells are combined with each other. As a result, you can find that there are 2 formula units within this unit cell. How there are 2 formula units within this unit cell? Look, these 2 oxygens are on the bottom face. So half plus half equals to 1. These 2 oxides are also on the face, but it is the top face. So half plus half, again 1. So 1 plus 1, 2. Now inside, this one inside, this one inside. All the remaining oxide ions are inside the unit cell. So each one should have contribution 1 each. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 10 plus from the top surface 1, from the bottom surface 1 more. So 10 plus 1 equals to 12 number of oxygen. Now calculate the number of A cations. This one is completely within the unit cell. But this one, and this one on the vertex means 1/8 part are inside, 7/8 part are outside. So 1 by 8 into 4 equals to half. Here also 1 by 8 into 4 equals to half. So half plus half equal to 1, 1 plus 1 equals to 2. So 2 A units are here. Now how many B units? Here this B is completely inside the unit cell. Here this B also completely inside the unit cell. So 2 B cations are there. Now these B cations are on the edge. On the edge means 1/4 are inside and 3/4 are outside. So how many on the edge? 1, 2, 3, 4, 5, 6, 7, 8. 8 into 1 by 4. That is 2. So 2 plus 1 equal to 3 plus 1 equal to 4. That means A2B4. Now count the oxygen. Oxygen is 12. So A2B4 12. That means there are 2 formula units. If the stoichiometry is AB2O6. Multiply AB2O6 by 2, then it will give A2B4O12. And this is literally A2B4O12. Okay. Now, let me just jot them down. The stoichiometry is AB2O6 as it is described here. A is typically, now this is one more information for you, that this A is actually a divalent cation. On the other hand, this B are actually pentavalent cations. Okay, so among this, out of this A, there may be magnesium 2 plus, zinc 2 plus, cobalt 2 plus, nickel 2 plus, cupric ion, etc. And V is a pentavalent cation. These pentavalent cations may be tantalum, antimony, niobium, etc. The structure consists of AO6 and BO6 octahedra. Look, this B is surrounded by 6 oxides, and this is octahedral structure. On the other hand, this A is also surrounded by 6 oxides, and they are surrounding A in octahedral manner. Again B. It is an ordered cation substitutional phase of rutile where the cation stacking changes from MMM to ABB ABB. Look how ABB ABB. The A cations, four A cations on the vertex forming the A layer. This body centered B cation forming the B layer, and this edge centered edge, that means the B cations which are belonging to the edge, they are forming the B layer again. Now again repeating, A layer on the body, B layer on the edge, and B layer in the body again. So it is A B B A B B. Now more accurately, if you want to say, then this is actually A1 B1 B2 A2 B1 B2. Why? Look, the projection of this A cation does not go through any A cation on this layer. So this layer and this layer both are formed by A, but they are different layers. So if this one is described as A, this one must A1, this one must be A2. And this one again A1 because the projection of this cation goes through this cation. So this layer is repeated here. So this one is A1, this one is A1, but in between this one is A2. Similarly, this one is B1, and since the projections are different, so this one is RB2. Again, this one with same projection with this one, so this one B1, this is B2. Okay, so it is A1, B1, B2, A2, B1, B2. Each A bivalent cation is surrounded by 6 number of B pentavalent cations. On the other hand, each B pentavalent cation is surrounded by 3 number of A divalent cations. There are two formula units in one trirutile unit cell, as it has been discussed, and finally, this type of structure is adopted by these compounds: iron tantalate, cobalt tantalate, nickel tantalate, cupric tantalate, cupric antimonate, zinc tantalate, magnesium tantalate, chromium antimonate, manganese tantalate, etc. So that's all about rutile and trirutile. Thank you and have a nice day.